For decades, one question has haunted every physicist who has ever looked up at the night sky and done the math. If the universe is so vast, if there are hundreds of billions of galaxies, each one packed with hundreds of billions of stars, and if life only needs the right conditions to spark into existence, then where is everybody? This is the Fermi Paradox, and for almost 80 years it has remained one of the most unsettling open questions in all of science. Now, theoretical physicist Michio Kaku, one of the most recognized voices in modern physics, is saying something that is sending ripples through the scientific community. He believes the James Webb Space Telescope may have already started giving us the beginning of an answer, and it is not the comforting one most people were hoping for. Let's slow down for a second, because to understand why this moment matters, you need to understand exactly how strange the silence really is. In 1950, physicist Enrico Fermi was having a casual lunch conversation with colleagues about the possibility of alien civilizations. The math seemed to favor life everywhere. Billions of stars, billions of years of cosmic history, countless planets in habitable zones. Statistically, intelligent life should not just be possible. It should be common, loud, and detectable. So Fermi asked a simple, almost offhand question that has haunted scientists ever since. If they are out there, where is everyone? No signals, no probes, no megastructures, no unmistakable evidence of engineering on a cosmic scale. Just silence. Decades of increasingly powerful telescopes, and still, nothing but silence. For a long time, that silence was explained away with a simple answer. We simply had not looked hard enough, or far enough, or with strong enough instruments. But that excuse is getting harder and harder to make, because the instruments have changed. The James Webb Space Telescope is not just an incremental step forward from Hubble. It sees in infrared light, which allows it to peer through cosmic dust and stretch its vision back further into the history of the universe than any telescope built before it. It can analyze the faint chemical fingerprints in the atmospheres of planets trillions of miles away. It can catch light that left its source before the Earth itself had finished forming. And what it has found so far has physicists divided between excitement and something closer to unease. Here is where Kaku's warning becomes relevant. Michio Kaku has spent his career explaining the deepest ideas in physics to the public, from string theory to the nature of time itself. He is not a fringe figure. He is a professor of theoretical physics, who has spent decades thinking about exactly this kind of question. And in recent interviews discussing Webb's discoveries, Kaku has pointed to something that should make anyone pause. The telescope has been finding things that should not exist according to our current models. Massive, fully formed galaxies sitting in a universe that, according to the standard timeline of cosmic evolution, we're simply too young to have built them yet. Structures that look mature and settled, appearing in an era when the universe was still supposed to be in its chaotic infancy. It is as if you looked at baby photos of someone and found a fully grown adult standing there instead. That detail alone does not answer the Fermi paradox directly, but it does something arguably more important. It tells us that our understanding of how quickly complexity can emerge in the universe might be wrong. And if galaxies can form far earlier and far faster than we assumed, then the ingredients for life, heavy elements, stable stars, rocky planets, could also have been ready far earlier than anyone expected, which means the window for life to emerge somewhere else in the cosmos may be wider than scientists previously believed. More time, more opportunities, more chances for someone, somewhere, to have already had a multi-billion-year head start on us. And that is exactly what makes the silence so much stranger. Now let's talk about the discovery that has genuinely shaken the exoplanet science community, because it connects directly to this conversation. In 2023, using Webb's incredibly sensitive infrared instruments, a team of astronomers turned their attention to a planet called K2-18b, sitting about 124 light-years from Earth. This is a sub-Neptune world, larger than our own planet, orbiting inside the habitable zone of its star, in the range where liquid water could theoretically exist on its surface. Webb's instruments picked up something extraordinary in the planet's atmosphere. traces of a molecule called dimethyl sulfide, along with its close chemical cousin, dimethyl disulfide. Here on Earth, there is really only one significant natural source for these compounds, and it is not geology, it is biology, marine phytoplankton, living organisms. Let that sit for a moment. A telescope, sitting 1,000,000 miles from Earth, aimed at a point of light more than 100 light-years away, may have picked up the chemical signature most closely associated with life as we know it. To be absolutely clear, this is not confirmed proof of alien life. Scientists have been careful, repeatedly, to stress that the detection needs to be verified, that there could be exotic, non-biological chemistry we do not yet understand happening on a world unlike anything in our own solar system. But the fact that this conversation is even happening in a peer-reviewed, mainstream scientific context is itself historic. We are no longer only asking whether life could exist elsewhere in principle. We are pointing real instruments at real candidates and measuring real chemistry. This is precisely the kind of discovery Kaku has spent years anticipating. In public appearances, he has repeatedly emphasized that the search for biosignatures, chemical fingerprints of life detectable across interstellar distances, is the single most promising path toward finally answering whether we are alone. And Webb was built, in part, with exactly this kind of detection in mind. So when a molecule strongly associated with living organisms shows up in the atmosphere of a distant world, it is not just an interesting footnote. It is a preview of the kind of evidence that could eventually tip the entire debate. But here is where the story takes a darker turn, and where Kaku's warning becomes something closer to a caution, rather than a celebration. If life, even simple microbial life, turns out to be common across the universe, spread across countless planets like K2-18b, then the Fermi Paradox does not get easier to explain. It gets harder, because simple life existing everywhere does not answer the real question. The real question was never just about life. It was about intelligent, technological, detectable civilizations. And if the raw ingredients for life are abundant, if biology is not some impossibly rare cosmic accident but something that happens routinely, wherever the chemistry is right, then the silence becomes even more disturbing. It suggests that something is happening between the emergence of simple life and the emergence of a civilization capable of broadcasting its existence across the stars. Something is filtering most life out before it gets the chance to become loud enough for us to notice. This is the idea scientists call the Great Filter, and it is one of the most sobering concepts in modern astrobiology. Somewhere along the evolutionary path from simple chemistry to a civilization capable of interstellar communication, there appears to be a bottleneck, a stage so difficult, so improbable, or so dangerous that almost nothing manages to pass through it. And the deeply uncomfortable question that follows is this: is that filter behind us, meaning humanity already beat impossible odds just by making it this far? Or is the filter still ahead of us, waiting, meaning every civilization that reaches our current level of technological development eventually runs into something that destroys it before it can spread across the stars? Kaku has weighed in on a related and equally unsettling idea. This one connected not to biology but to strategy. For years, there has been an ongoing and genuinely contentious debate in the scientific community about a practice called messaging extraterrestrial intelligence. The idea is straightforward on the surface. If we want to find aliens, why not just send a signal out into the galaxy announcing that we exist? Some scientists support the idea enthusiastically. Others, including Kaku, have pushed back hard. He has publicly described the practice of deliberately broadcasting our location and information about Earth into deep space as a genuinely bad idea. His reasoning draws on a simple but chilling analogy, one that echoes classic science fiction, but is grounded in real strategic caution. We cannot assume that any civilization advanced enough to detect our signals and travel here would be friendly. History on our own planet offers a blunt lesson. When a more technologically advanced civilization encounters a less advanced one, the outcome is rarely equal partnership. It is almost always domination, exploitation, or extinction for the less advanced side. This is sometimes described by scientists and science fiction writers alike as the dark forest hypothesis. Imagine the universe as a silent, dark forest at night. Every civilization is a hunter, alone in the dark, aware that other hunters exist somewhere out there, but with absolutely no way of knowing whether they are peaceful or hostile. In that kind of environment, the safest strategy is not to announce your presence, hoping for a friendly response. The safest strategy is to stay silent, stay hidden, and treat every unknown signal as a potential threat. If even a small fraction of civilizations in the galaxy behave this way, if being loud and visible carries real existential risk, then the silence we observe across the cosmos is not necessarily evidence that nobody is out there. It might be evidence that everybody who is out there has learned, the hard way or through simple caution, to keep quiet. Now bring Webb's discoveries back into this picture, and the entire conversation gets heavier. If the telescope is confirming that the ingredients and conditions for life were available earlier, and more widely across the universe than previously believed, then the raw number of civilizations that could have existed across billions of years and billions of star systems becomes staggering. And if none of them are broadcasting, if the sky remains silent, despite the mathematics suggesting it should be full of noise, then either almost none of them ever survive long enough to become detectable, or the ones that do survive have very good reasons to stay quiet. Neither possibility is particularly comforting. There is a third layer to this discussion that deserves attention, because it connects directly back to the physics. Kaku has spent his entire career trying to explain to the public. Webb has not only been finding potential biosignatures on individual exoplanets, it has also been rewriting our understanding of how quickly the raw architecture of the universe, galaxies, star clusters, heavy elements, came together after the Big Bang. Some of the galaxies Webb has observed appear too massive, too structured, and too chemically enriched for the amount of time the universe had supposedly had to build them. This has forced astronomers to seriously reconsider models of early cosmic evolution that had stood largely unchallenged for decades. Why does that matter for the Fermi Paradox specifically? Because the entire question of whether intelligent life has had enough time to emerge and spread across the galaxy depends heavily on timing. If galaxies, and by extension planetary systems, and by extension the possibility of life, were forming significantly earlier than the old models predicted, then somewhere out there, there could be civilizations with not just a head start of a few thousand years, but a head start measured in hundreds of millions, or even billions of years. A civilization with that much more time to develop technology would not look like us with slightly better rockets. It would likely be operating on a scale so far beyond our current capabilities that we might not even recognize its output as artificial. This is part of what makes the ongoing silence so genuinely puzzling to physicists like Kaku. Extra time should make detection easier, not harder. And yet, as far as our instruments can currently tell, there is nothing. Some researchers have proposed even stranger possibilities to explain the silence, ideas that sit at the edge of testable science but are taken seriously in academic circles. Perhaps advanced civilizations do not expand outward and colonize the galaxy the way older science fiction imagined. Perhaps they turn inward instead, building simulated realities or focusing their technology on scales too small or too efficient for us to detect from light years away. Perhaps intelligence itself is a kind of evolutionary dead end, a trait that tends to accelerate a civilization's own downfall through war, environmental collapse, or runaway technology, faster than it ever manages to spread that civilization to another star system. Kaku himself has pointed out that humanity's own trajectory is not exactly a reassuring case study. We have had nuclear weapons for less than a century, and we have already come close to using them by accident more than once. If technological civilizations tend to develop destructive capability faster than the wisdom to control it, that alone could explain why the galaxy is so quiet. Not because life is rare, but because survival past a certain threshold of technological power is rare. This is why Kaku's comments carry more weight than a typical talking head soundbite. He is not claiming Webb has found aliens. He is not claiming the Fermi Paradox is solved. What he is pointing to is more precise and, in some ways, more disturbing. Webb is systematically removing the easy excuses. It is proving that the universe had the ingredients for life earlier than we thought. It is proving that biosignature detection is not just theoretically possible but is already producing real, debatable candidates like K2-18b. And with every excuse it removes, the remaining explanations for the silence get darker. Either intelligent life is far rarer than the raw statistics suggest, or something consistently stops civilizations before they can announce themselves to the rest of the galaxy. Or civilizations that do survive have very deliberately chosen not to be found. Think about what that actually means for us. We are a civilization that has been broadcasting radio signals into space for roughly a century now. In cosmic terms, that is barely a heartbeat, an almost undetectable flicker against the scale of galactic history. We have sent physical probes, including the Voyager spacecraft, carrying golden records with messages, sounds, and images meant to represent who we are, drifting silently into interstellar space. We have, on occasion, deliberately beamed messages towards star clusters, hoping someone might be listening. If the dark forest hypothesis holds any truth at all, every one of those actions could be viewed very differently depending on who, or what, eventually receives them. And this is ultimately the uncomfortable position Webb's discoveries have placed us in. We built a telescope powerful enough to start peeling back the layers of one of humanity's oldest questions. And instead of delivering a clean, reassuring answer, it has made the question sharper and more urgent. If we are utterly alone, if Earth truly is some kind of cosmic fluke that carries its own kind of vertigo, a universe of unimaginable scale with, as far as we can tell, only one small blue planet where anyone is paying attention. But if we are not alone, if the universe is in fact populated, and the silence is a choice rather than an absence, then the questions become even heavier. What exactly are we being cautious around? What happened to the civilizations that came before us and did not survive long enough to answer? And when, if ever, will we be ready to know for certain? Kaku's position, distilled down, is essentially this. We are standing at a genuinely pivotal moment in scientific history. For the first time, we have instruments sensitive enough to actually test some of these questions with real data, instead of pure speculation. Webb is not just a telescope pointed outward into space. It is functioning as a kind of time machine, showing us the universe as it existed billions of years in the past. And in doing so, it is quietly rewriting the timeline of when life could have first had the chance to emerge. Every biosignature candidate, every impossibly early galaxy, every rewritten model of cosmic history is another data point in an investigation that has been running, unofficially, since Fermi first asked his question at that lunch table in 1950. So where does that leave us right now, in this exact moment? We have a telescope finding possible chemical evidence of biological activity on a planet more than 100 light-years away. We have galaxies appearing, far too early and far too developed for our current models of cosmic history. We have one of the most respected physicists alive warning that broadcasting our presence into the dark might not be the harmless, hopeful gesture it once seemed. And we have decades of accumulated silence from a universe that, mathematically, should be far louder than it is. None of these pieces individually proves anything, but together they are forcing scientists to take the Fermi Paradox more seriously than at almost any point in its history, not as a philosophical curiosity for late-night conversations, but as a question that real data is finally starting to press against. If Webb continues finding more candidate biosignatures on other worlds in the coming years, and current survey plans suggest it will have the opportunity to examine dozens more potentially habitable exoplanets before its mission is expected to wind down, we may be approaching a moment where the debate shifts from asking whether we are alone to asking something far more specific and far more consequential. Not simply whether simple life exists elsewhere, but why. Across the staggering scale of time and space this universe provides, we still have not heard a single confirmed word from anyone. That is the warning underneath Kaku's warning. It is not that aliens are coming. It is that the universe appears to have had every opportunity to be loud, and instead, it has chosen silence. And the deeper Webb looks, the harder that silence becomes to explain away. If this kind of question keeps you up at night the way it keeps physicists like Kaku thinking, make sure you are subscribed, because Webb is nowhere near finished. And the next candidate signal, the next impossible galaxy, the next piece of this puzzle could be the one that finally forces us to rewrite everything we think we know about our place in the universe. Drop a comment and tell me which part of this unsettled you the most. The biosignatures on K2-18b, the idea of the great filter, or the possibility that the silence itself is a warning. And if you want to go even deeper, into how scientists are racing to answer whether we are truly alone, there is another video linked right now that you need to watch.